A positive charge, Q1, a positive charge, 9A, a positive charge, positive charge, positive charge, number 9, is 49 cm from a second positive charge. That is Q2, this is Q1. The second positive charge. Full stop. At what point in terms of Q and on the line joining the two charges is the electric field 0. So that's QA. That's QA. So we saw something like this before. Daniel, welcome. It's been long. Hope all is well. Have you been coming? I noticed because the whole of I was not around Thursday, Friday, but I know the whole of last week I didn't see me. So who can try this for us? I know we solved a question like this before. Someone should come and help us. That's how I want us to do today's one. Someone should come and give us hand. Anybody. It's no more than you can actually do it. We've solved something like this before. Someone should come and help us. Can you do it? Alright. You are successful. Yes. The stress is becoming too much. Hello? Okay. So please, solution. What I just need to do is to say plus Q. See what they're telling me? They said I have Q1 and I have it from a distance. So that the next one, which is Q2, they are separated by 49 cm. And 49 cm is something I said divided by 100 shilling, which will give me what in meter? 0.49 meter shilling. Okay. Now, if I have this, they are not telling me at what point in terms of Q, they are asking me for like a point, like another charge that I will have to place here. At what point will I place a charge so that there will be an equilibrium between the two? I don't know. I don't know what point it is. So let's say I call this x. Let's say I call this point, that point, x. And that point is going to have, this is 49 cm. So this is Q1. So let's say this is Q at point x. Remember what I taught you earlier when we were doing equilibrium. That it will simply mean that from this end to this end is going to be x. That means Q1 is simply occupying a position of x, while Q2 itself will simply occupy what? I know we've done this before. So you see that entirely Q2 is simply everything from this is our 0.49. 0.49. This is an equilibrium question. Everything from this end to this end minus this x is our Q2 position. So our Q2 position is simply 0.49 minus x. This is how you go about this kind of question. In order for us to find this position, you always need to have that in mind. So they can have questions, they can have positions where they can have situations where they call this A, they call this B. I know you are not in this class when we did this. You are following it. So what you do is to first identify, it's an equilibrium type of question, charge equilibrium question. So you identify the position from the first charge to that point you are looking for, that is the equilibrium point. Then from the Q2, which has covered the total distance back. So if I've done that, it simply means that to get the electric field now, it will simply be the E1 plus E2 equals to 0. Is this how we normally do it? So is E minus, should it? That is so that when it calls a quality sign now, you see now, how we do the equilibrium now, which is the same as saying E1 equals to E2. So what I will now do is to simply remember that this is the same as saying KQ square. Is it square or KQ over R square? I hope I'm still with human beings in this class. Or am I doing Nigerian movie for you? Please. So this is going to be, the Q here will be Q1, this one will be Q2, shall we? So if I know that, I will now remember that for Q1, the area is actually what? X, shall we? So x squared. Why this one? The area is what? 0.45 minus x. Awesome. So if you learn just this equilibrium question, you see that it's looking like something you can actually memorize. Once they ask you that type of question, you already know. The only problem you are going to have is just you knowing how to find this position. Once you're able to find it, equilibrium is equilibrium. What you have this side should equal to what you have this side. So if I've done that, I can now substitute k will cancel k, so that I will now have q1 over x squared equals to q2 over 0.49 minus x all squared. Okay, remember that my goal is to make x subject of the formula. Those people that were telling me in the last class, why don't you just put value and solve? You see that this one, they did not give us any value for the q. This one is different. You know you are the one I'm talking to. I am coming fast. So you see, in order to make x subject formula, that is why different or no different, it's just q that did not give us. That is why I said, find a way to get your q and q to be one side. The things having x to be on another side. Experience is better than willpower. And habit is better than dedication. If you make it a habit, even if you are tired, even if you are doing it one kind, you'll be better than somebody that each time he or she is doing it, that person is doing it 100%, but has to do it maybe once in a while. So, I'm giving you habit to meditate Once you are solving equilibrium question, you remember all these things I've given you. Remember just that you always have to find a way to put your Q one side, put your X position one side. So I'll get this down here, get this up here, so that I'll have Q1. This is the same as cross multiply. Share you know. Over Q2 equals to S squared over 0.49 minus X all squared. Okay. If I want, I can stop here. But since the goal is to make sure that I get the position, I will solve for do mathematically. Can I do mathematical? Can I claim this? It's in your book. Please, if you've not paid us for tutorial class and you're in this class, you are not supposed to be here. Thank God, the minute I finish teaching you capacitor and I teach you AC and DC currents, that means we are done with everything electricity. We'll now start magnetism. I told you that this semester physics is supposed to be powerful. You're supposed to understand it like if there is nothing there. So please, I'm allowing those of you that are in class without paying, follow us to solve questions. Once I'm about to start capacitor class, I'll pursue anybody that have not paid us for class. So please, try, send me money to their accounts. Don't come and sit here. After enjoying our class, you go home. Don't go and miss 1-0. You purposely miss 1-0. Send it to your brother that is using the same OPay account. Am I too fast? Oh, sorry. So that means that if I make X other than formula, you can see that that thing is the same thing as saying Q1 over Q2 equals to X over 0.49 minus X all squared. Do you agree to this thing? Okay. So if you agree to it, it simply means that I can say take the square root of both sides. So if I take the square root of both sides, this will now be Q1 over Q2 square root equals to X over 0.49 minus X. This will get out. So that I now have I want to bring this side, bring this one this side. And I have X over 0.49 minus X equals to root Q1 over Q2. Okay. So making X solid on the formula, X will be equals to 0.49 minus X, then root Q1 over Q2. Hope I did not confuse anybody. Why are you sitting like someone that's saying okay, so please, that's why there's not give us Q. We are going to stop there. So it's more like an expression. But if you check the B part of that question, they gave us something. So we can use the B to further it. So, but please, this question that has to do with equilibrium, there's nothing there. That's just what I'm trying to get to you. Just know how to find the position. That's distance. Once you're able to find the distance, remember what we did in equilibrium. Once they say the electric field to be 0, they are talking about equilibrium. So do it. So this is where we are stopping. Somebody will want to ask me, why don't you simplify? But this is an expression because they did not give us this. As they gave us this, by the time we get it, we do what we do, collect items. But we'll stop here. So X, that position is like this. So trying to look at the second part of that question, the B part of the question. Look your follow. Are you sure? So the B part says, if Q1 and Q2, the B part, that is 9B, if Q1 and Q2 are 3.6 times 10 Q minus 3. This minus 3. Please, you can check your textbook for me and be sure if what we have here for raised to power is correct. Is it raised to power minus 3? Yes. Respectively. Thank you. So calculate Thank you. So if Q1 and Q2 are 3.6 times 10 raised to the power minus 3 coulomb and 9.3 times 10 raised to the power minus 3 coulomb, respectively, calculate explicitly the position of the zero electric field. So all I need to do is just, since we've gotten the electric field position at equilibrium, this is the position at equilibrium, all I just need to do is to substitute these values for Q1 and Q2. That's just it. Just substitute for Q1 and for Q2. That's just it. So I can clean. And you do. How are you? Welcome. So I substitute. So that I now have that x will be equals to 0.49 minus x root 3.6 times 10 raised to the power minus 3 all over 9.3 times 10 raised to the power minus 3. I know I'm not fast. But your punch for me, what do you have? Physiotherapy, are you following? I know you are not following. But tell me, what's the problem? You are hungry. That's why you are not following. Just persevere. I don't know what to say now. Because the people are supposed to be selling something. The woman is finding it hard to trek to this place. But I will make effort to see that by next Saturday, somebody is there. I promise. Just persevere. Punch this thing for me, what do you have? 0.622, like this. Are you sure? 0.62217. 171 like this now, approximately. Okay. Then multiply by 0.49 minus x equals x. Okay. Sure, you know that this thing is actually 0.6. I will not be wrong if I say this is 0.6. But anyhow, carry this thing now. Anyhow you want to do it. Carry this times this, carry this times this, what do you have? Do for me 0.622 times 0.49. 0.30. Our computer going now. 0 point again. 3048. Okay. Minus of that? 49. Okay, 49. I'll still put 49 here.
No, across that is 4878.
Okay, thank you. Okay. But carry on, okay, minus. Should it? And this version I can say collect so that this can cross equality sign so that I have x plus 0.62x equals to 0.304. If you add this up, 1 plus, you hope you know that this is the same thing as 1. So 1 of this plus this, what do you have? 1.
6.
Okay. So I can now say divide both sides by what? So that x, this will cancel. So that x will be equal to, oh yeah, give me the answer. 0.187. 0.1. Somebody is getting 179. Well, so which one is this one correct? Please be sure. So that means that this is approximately 0.19. Sure, you know, meter. So that is my position of x. That is my position of x. So I've gotten x, which means that if I come to that place where I have Q1 and Q2, the place I called x is actually 0.19. And if you remember, we said that means that from Q1 to Q will be equal to 0.19. Then Q2 to this position is actually, if you remember, Q2 to Q will simply be the whole measurements, the whole of this minus this part. Sure you know. So I have 0.049 minus 0.19. What was the answer? 0.3. Oh yeah, the next one. We have to be fast because I want to do capacity. Number 10. State Gauss law. You still remember Gauss law, but let me state it. It says that It says that the electric flux through an enclosed system, is state Gauss law. The electric flux through an enclosed system is proportional to the charge enclosed. Electric flux through an enclosed system. Electric flux. If you miss the class of electric flux, your mind might be telling you what is now flux. We've done this, and I said that flux is simply talking about all the lines of charge, or you say all the electric field intensity that you have on the surface. That is the proper definition of flux. So it deals with all the electric field intensity, all the flux lines that you have on the surface. That's what flux is all about. Now, and I said, Gauss law said that the electric flux that flows out of the surface, that is through an enclosed system, the electric flux through an enclosed system going out is directly proportional to the charge enclosed by that system. So what Gauss law is saying is that you don't know the number of charge, you don't know the charge, you don't know the amount inside. That the only way you know it is what is coming outside of it. That is the same thing with quoting Bible, by their fruit you shall know them. So that is just what he's saying. The output is what tells what is inside. So that's Gauss law for you. The answer is actually 0.19. That is that position and the position of equilibrium. But we have to find this one since we put that this Q2 is actually 0.49 minus x. So we just have to solve it complete. That's why it's tutorial. We have to do everything. You learn everything so that when you go exam, you now know what your answer is. So the next part of that question is, show that electrostatic field E associated with point charge Q is given by E equals to Q over 4 pi epsilon naught r squared. Shebi we've done this thing before, but let's do it fast. You know why I don't like repeating myself is that once it gets to 4 o'clock, people don't used to behave yourself. So I want to be skipping some questions so that we'll solve. Because once it gets to 4, you forget that we are learning. You now start being you want to go home. So I want to manage my time well today. So I'll be skipping some questions I know we've solved before as we progress. Let me just solve that one because it's foundation to a lot of things. You've not told us what tutorial again. I said in that class, that first class, that this is the symbol for electric flux. And that electric flux talks about the total electric field or total electric field intensity, or you say total electric field lines on the surface. So electric field intensity on an area, EA. I also said that this electric flux is also equals to Q over E naught. How did we get it? We got this formula that day from this. If you don't understand, go and check my video, go and watch it. So, but Gauss law is now saying that the whole electric flux you have, so you have EA equals to Q over E naught. So we are now saying that since we know that charges move as a sphere and not as direct lines, that the area we are putting here, area of a sphere is simply go to the volume. Volume of sphere is what? 4 over 3, Pi what? I want you to be the one to give me volume of sphere. Is it Q? Oh yeah, let's differentiate this. If I differentiate this, what will happen? This will come here, this will come here and do what? Multiply. So if 3 multiply, I get what? 12 over pi r n. 1 will be subtracted here, Shebi. But if 3 go here, 3 go here. So I'm now going to be having that the area is actually 4 pi r squared. Please, I told you, anytime you want to get the area of anything in physics, don't go and say in mathematics they used to say no, just know the volume. Differentiate the volume for me. Because sometimes if you can't carry all the areas and put there, you might make mistake. But once you know volume differentiate, that's the area you need in physics. So I'm now going to be having 4, that's E, sorry. E into 4 pi r squared equals to Q over E naught. Making E subject of the formula, I have E equals to. So I'm now going to have Q over 4 pi r squared E naught. Is it not true? So that I can easily now have this to be the section I say E equals to Q over 4 pi epsilon naught. There's one invisible one here. Let's have one here. Then I have Q over r squared. Now, do you remember that when we started, sure you know that this thing is the same thing with this. But if you remember, there was a time when we said that Q is equals to 9 times 10 raised to the power 9, and that K is also equals to 1 over 4 pi epsilon naught. Do you remember? Yes. I said something like that before. So if that be the case, I can replace everything here to be K, so that E will be equals to K, then Q over R squared. So, please, if you missed the class that I did when we started chapter 2, go back and rewatch it. So that is that. So that is how you prove it. So to show that electrostatic field E associated with point charge is given by Q, is given by E equals to Q over 4 pi epsilon naught arrow square is simply what we've just done here. So they are trying to say that once you've done this thing up to this point, this is where you are stopping. And remember that this is the area of the sphere. Area of sphere. So, but going further, you go ahead and show that one so that you relate this particular thing to electric field intensity. So the next one, the B part. The B part, they said calculate electrostatic field strength E due to spherical metallic conductor of radius. Let's be fast, we'll do that one. Let's do that one. Please, I know you are hungry, I know you are tired, but it's not my fault now. We are used to this, are we not used to it? I've told you before, if you are coming, you come with what you will eat. You can even carry lunch box to school. You are not too old to be carrying lunch box to school. You are not too old. If you love this your school, your academy is too much. You should have a lunch box. If possible, tin and nylon. There is nothing wrong with it. So they said, do you remember, please, do you remember what I told you about Gauss law in our first class? I told you that according to Gauss law, that whenever you have, for example, point charges, and Gauss law is saying, if you use Gaussian surface and enclose this charge, the whole charge here, leaving the surface, will still appear here. Is it not true? Charges tend to move to the surface. So for that reason, if I have a point charge this way, what I have here, this is from this end to this end is R, then and this one to this one. Okay, let me do this way. Okay, let's say this is small r, and this one now is big R. What I'm saying is that if electric field here is E equals to KQ over R squared, that is the same thing with what will be here, because charges will come outside. And if another case come, whereby we have our R, small r, and we now carry the Gaussian surface and put exactly on top of it, the same thing will happen. Charges will pass through, the same number of charges will pass through. But we are not saying that if we have charges on the surface, and we now come and carry Gaussian surface and put inside, you and I know that charges don't like to be on the inside. It tends to move out to the part, that is the surface and the sharpest points. The charges will remain outside. It will not have any charge on this side. So the Gaussian surface here will be zero. The charge, the electric field on this particular case will be zero, because there will be no charge on this inside. So when you have a situation like this question that we are about to answer now, let's use the question to answer it. So this question that we're answering talks about these three cases, and I now have taught it. It says, calculate the electrostatic field strength due to a spherical metallic conductor of radius 20 cm. So the R is 20 cm. So 20 cm divided by 100, give it to me. Please be active. So 0.2. So if that is the case, they said inside the sphere, what will be the electric field? Zero. And inside the sphere, the electric field will be what? There is no need to calculate. You see it? So if I'm calculating electric field, metallic conductor of radius, and they say inside the sphere, the electric field here will be zero. Now they said just outside the sphere. Just outside the sphere. Just outside the sphere. If you like looking at this thing like you don't understand it, if they post YouTube video, watch it. It's not a post YouTube video, you are saving data. When we come to class, he will teach it. If we've done something and we recorded the video, go and watch it, please, I beg you. So just outside simply means, if I have this now, as I have this, let's say I now have to calculate the electric field just outside this sphere. Just outside this sphere. Because they did not give me any measurements. Okay. Yes, they did not give me any measurements outside that sphere. They did not give me any measurements outside that sphere. So that means That means in that case, just outside, this is the sphere. This can be on the surface of that sphere, which means that the radius is the same thing. Yes. So I'm going to maintain that. So I'm going to be using E equals to JQ over R squared. Somebody somewhere will be asking, but they said outside. This is also outside this sphere. Please note that. So that I'm now going to be having E equals to K is 9 times 10 raised to the power 9. The charge is 4 times 10 raised to the power minus 6, all over. The radius there is 0.2 in meter. I have punch it for me. What do you have? Everything, punch everything. Let's be fast. 0.2 squared. 0. Okay, thank you, bless. Thank you. I have punch everything for me. What do you have? Punch. What is the answer? 9 times 10 raised to the power 5. And the unit of electric field is what? Do you still remember this formula? Yes. So this is volt, Shelly. This is meter. So I can have volts per meter. So unit of electric field intensity depends on what you are solving, though. But have it in mind that the general unit is this. So if I have that, they said just 2.6. This time 2.6 meter from the center of the sphere. Okay. 2.6. Have you copied this? But be fast. Let me draw that one. Okay, so E will be equals to 9 times 10 raised to the power 9, then 4 times 10 raised to the power minus 6, all over. I have 2.6 all squared. I have punch for me. I hope you are not confused. Am I confusing you? Who am I confusing? I'm confusing you, let me know. So that I won't be too fast. I want everybody to follow you. I have punch. What do you have? 5? Come again. 5 5.3 times 10 raised to the power 3. 5.3 times 10 raised to the power 3. Is that 53,000? What do you have? 5 You have 5.3 or 5. You have 5.325 Raised to the power 10. 19. Lord of Jesus. Zachariah, I want to get man. Jesus, open and down. This can be right. Check, 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 check. 9 times 10 is 9 times 4 times 10. So please, the key thing is, I know those of you just coming for the first time. Darkness is upon the face of the deep. But what I want you to understand is that once he's talking about sphere and they're telling you to find electric field inside that sphere, it will always be same. Then anything outside or on that sphere will be you will have to make use of the formula for electric field. Then considering now the radius. So in this case where it's outside the sphere, you are using this radius. But when they say 2.6 from the center of that sphere, that means the radius actually is from this end to this end. This is the one you're using. So note that. So let's move. So the correct answer is this and this. This one approximated it, and it's the same thing with this. So which is in volts per meter. That number 11, I will not do it. That number 11, I will not touch it. You are doing it. Somebody wants to ask me, what of the action of point phenomena? I've told you before that charges tend to gather at the steepest part or the sharpest part. So you are the one doing it. Then for thunder protector and Van der Graaf generator, you can read it up. But have it in mind that the reason why this works very well is because of the fact that as you place it, whatever charge is hitting the center of that particular protector or the generator, you see that it will be absorbed because there is no room for charge to enter inside it using that point of action phenomenon. So whatever charge on the surfaces will have to bounce back. So it's not hitting directly because it has been made in such a way that it can't absorb charge. So you're reading it up. Now, the next one, they say draw electrostatic field lines around a positive charge. Okay, I think we'll do this one. But you can read this one up. Let me solve the calculation once. You can read that one up. When you hear that something is earthed, when you hear that they earth something, what does it mean? It's passed to the ground, sharp. So you are reading it up. You are reading up for me, what does it mean for something to be earthed, or for a particular, charge to be earthed, or plate to be earthed. What does it mean? So you are reading it up for me. So I want to solve the calculation one so that I can be able to enter capacitor today. So the next question there is number, is it 12? You say 12 in your head, thank you. You know what electric field potential is already now? Electric field potential is simply the work done in moving a unit positive charge from infinity to another point. So it says the work done in moving a charge from one point to the other. So let's solve 12C. Okay. They said, I have this two plane parallel conducting plates. And are 1.5 centimeter apart. Okay, so they have the horizontal. This is their distance. What's this in meter? 0.015 in meter, Sherry? Okay. One above the other in air. So the upper plate is maintained at positive potential of 1.5. So this upper one, is having V equals to 1, 5. Watch, look at this. They said the lower plate is earthed. That means that the V here is equals to 0. Sure, you know that thing they tell you earthing. If I say earthing, so it cannot shock you. Do you still remember that time? They tell you the earth parts when you are bringing wire. You say this is the positive one, this is the negative one. You say this one, you are putting it inside so that it doesn't shock you. Do you still remember that kind of talk? So that earthing, when you hear the plate is earthed, the second one, that means that it's 0. The voltage is not carrying, it can't carry charge. So there is no charge being carried here. You know that the work of potential difference is to carry charge, work done in moving charge. So I normally, okay, let's continue. So the next said, calculate the number of electrons which must be attached. So, do you remember Q equals to NE from quantization? Yes. Once they tell you number of, and I told you in our last class that this thing also means atomic number. Do you still remember? So number of, that means I'm going to do NE equals to Q over E. So they said, calculate the number of electrons which must be attached to a small drop of mass. A small oil drop of mass. Oil drop of mass. The mass equals to, please, somebody should check for me. Is that meant to be in gram or kg? Okay. Gram. Okay. If it remains stationary in the air between the plates, shall you see, if you've observed one thing, anytime I'm teaching you, full stop is very important in physics. You are paying attention to your full stops and it's very important. Anywhere you see full stop, it's very important you pay attention to it. So notice that here, they gave me something about this, and at the end of the day, told me something about this one as well. So if I have to find electric field for this, if I want to find electric field for this, let's say I remember that actually voltage is equals to ER. Do you remember our last class? So that means to get electric field, which is the same as saying V over R. So I want to get electric field for this one. I can't get electric field for this one. Sure you know. Because it's earthed now. So that means this is going to be the same as saying E equals to 1/5 over 0.015. Punch it for me. What do you have? The electric field. Punch. Huh? 100,000. Are you sure? Please check. That is volts per meter, right? Okay. So that is for the first plate. The second plate, we are not checking its electric field. So, but what actually are we looking for there? If you check the number of electrons, should be before any other thing. So I found the electric field for the first full stop. I'm not finding for the second full stop because it's earthed. I continue to the part of the question now to solve for number of electrons before looking at any other thing. The problem is that you want to get final full stop. So please, let's just use that approach for this our second semester physics. Okay. So do you remember I once told you that force, I told you that force is equals to, remember, force is equals to kq square over r square. Do you remember? And I also told you that force is equals to QE. Do you remember? If you are hungry, are you the same type of person you are when you are not hungry?
Yes.
Okay, you are the same person. That means you want hunger to kill you. See now, that means when the force we are talking about is simply due to the charge and the distance of separation. This is the one I'm using, Coulomb's law. But when I'm talking about the force due to the electric field and the charge, this is the one I'm supposed to use. Get the point now? So for that reason, I am going to be applying this particular force. Somebody will say, why didn't you apply this one? If you want to solve for that one, you can solve as well. But what I know is that for the fact that there is an oil drop in between these two plates, that means that for that to be so, there is an electric field created on this region. Remember, this oil drop is assumed that this is more like an assumption. They did not say it's placed down. They did not say it's on this. It's more like where I am assuming that something is hanging. So it's more, for me to assume this thing, I am assuming it that is in an electric field. So that assumption is more like, okay, I'm saying that let's take it that in an electric field is able to hang in air stationary. So for me to make that assumption, that is why I'm going to be using this to solve. And notice that if I'm going to be using this with that assumption, this question is more like I'm assuming that oil drop. So if I'm going to be making that assumption, it simply means that for it to be stationary, it's not moving. It's not moving, yes, but there is something acting on this object, which is G. Do you agree? Everything on Earth that is not, that even on the floor, is being acted upon by gravity. So that means that there is G acting on this, and then the mass itself. So that means that for this force I have here, I'm going to be having mg equals to QE. Mg equals to QE. If you want to go and do your own by using this thing, this particular force to solve, I did not say you are wrong. But me, I am using this particular force to solve because I know that this force has to do with when electric field is involved. And the electric field is definitely involved here. Because you can't tell me that oil drop is there and just hanging. How? The only way it can do that is a situation whereby I'm taking it that electric field is making it stay there. There is electric field on it, making it hang. In that case, that's why I'm using this. So if you have to use this, for those of you that will go and be saying, why did he use this one and not this one? That's the reason I'm giving you now. So this is 9.8 times 4.9 times 10 minus 12 equals to, I don't know this Q, but I know my electric field. And you know that this is the only one that has that electric field there. So 100. Hope you are sure that you got 100,000. But please, before I do this mass, sure you know that this thing is in gram. But in physics, we like using kilogram. But let's convert this thing to gram. So here I will divide. So I will divide by 1,000, which is the same as saying times 10 raised to the power minus 3. Is it true? So that means this is the same as saying 4.9 times 10 raised to the power minus 3. Please check well for me. Okay. We'll punch the two. What do you have? Punch the two. What do you have? 4.8. 4.8. Okay. So please, I converted mine to kilogram because that's the SI unit. I can't be using meter and using gram. It's meter. No, no. Okay, so I now have Q 100,000. So I'll divide both sides by 100,000. Divide. This thing is not looking like my board. Just doing scatter work. Oh yeah. So I do 100,000. So my Q, give it to me. What do you have? Huh? 4.80 times minus. Please check. Oh. Is she correct? So, columns. So remember, the reason why I have to get charged, the reason I have to get charged is so that I can be able to solve using that quantization rule. Anytime they ask you number of electrons in physics, the only way to find it is by using that our quantization of charge formula, which is Q equals to ME. This thing stands for number of atoms, it stands for number of electrons, it stands for number of protons, and you know that that is true. Because if you remember what they told you proton number is, they told you that it's the atomic, that is the number of atoms, or you say number of electrons, or number of protons, that time that you did chemistry. They tell you proton number, mass number. Here they tell you mass number is now number of proton and neutron. Do you still remember? So that means if this is number of electron, number of proton, you see atomic number. So I'm going to be doing N equals to Q over E, so that I can put this and then put, and number of electron itself has a charge which is constant, which is 1.602. Is it minus 19? So this is going to be N equals to 4.802 times 10 to the power minus 19 all over 1.602 times 10 to the power minus 19. Punch for me. What's N? 3. N is 3? Yes. Are you sure? Yes. Okay. So N is equals to 3. Somebody might want to ask me, what is the unit? Do you remember in your secondary school they told you the unit for atomic number is AMU? Here they tell you atomic mass units. You still remember A.M.U. That time you did isotopy in secondary school. So I don't have reason to put A.M.U. That is why in physics we just take it that it has no units. But the actual unit for atomic number is A.M.U. So we normally use that atomic mass unit because of the fact that first of all, before we started using atomic number, the first person that postulated the use of periodic table started it out with thinking that atomic mass is actually the main thing to assign to elements. Before, and that's the Russian man, Mendeleev, before Henry Moseley came with his own modern periodic table. So the one we are using actually is Henry Moseley's table. I know you normally hear Mendeleev is the father of periodic table, but the periodic table we are using is actually Henry Moseley's periodic table, the one he modified. So that's why I'm going to be leaving this as strength. So that's the number of electrons. It's not confusing. It's not confusing. It's not confusing. So let's progress to this next part. They said I shall assume. Okay, let's assume again because the first one is also assumption. They said I should assume that the density of air is negligible in comparison with that of oil. If the potential of the upper plate is suddenly charged to minus 1.5 volts. Okay. Sure, you remember that I once told you that if you are not told what charge it is, you assume that that charge is positive. Do you remember? I once said that charge means positive. But if you are told electron, you now know that it's negative. So in this case, the minute they said being minus 1.5 volts, that means that whatever charge I have here, being positive, even the charge here should be negative now. So that they are not saying that instead of being 1.5, the situation there is now minus 1.5. And notice something, the main thing there is that it started moving downwards. The initial acceleration of the charge drop. You will see, I have not solved anything. For those of you that are confused, I don't want situation where as you are learning this thing, you are saying, because he said this one, let me keep this one in my head. He said it like, let me know. Let's clean the board now. Analyze what they are saying here. Let's say this is the plate, minus, minus, minus. This one is empty, I don't know anything about it. But this thing now is now moving down, no longer stationary. It's now moving down. Eh? I didn't hear you. The V is 1.5. The 1.5 is the distance now from here to here. Are you there? The V is 1.5 now. The 1.5 is actually the distance from the one that is earthed to the one that is not earthed. That's what the 1.5 is for. You are not seeing it well. This hunger is touching you. Should we have one that say you are hungry? This hunger is touching the uppermost part of your brain. Sure, you know that in this my teaching life, I've seen students that died because of hunger. God forbid, I'm not lying. Real life. I've witnessed students in this school, not with education, that died because of hunger. For same, how do you know? Okay, you think they're coming academic graduate for nothing. See, real life. So please, if you are really that hungry, nothing is ending, you can go home, watch the video. And don't stay and be punishing yourself. I beg you. I know what I'm saying. It's real life. When we got there, we noticed the girl's eyes, like, one of the hospital for days, and the thing has caused her issues, actually. I hear chill like this. When she died, I hear like this. It's not a joke. So please, if you are hungry, go home. Go and rest. You watch the video. You watch the video. Don't stand be forcing yourself. Even if it's two people we teach, provided we make the video. And you watch it, calm down, watch it. But if you are not too hungry, you stay. But if you are very hungry, please go home. Don't stay here and kill yourself. Sometimes they will tell you hunger don't used to kill people. It's a lie. Open this. They will tell you I think the way it's in those days, not now. So you see, she's taking my advice seriously. Well, it's true. So see, I have this moving down, mg. If you remember, that time we did elevator, something in an elevator, when there is a force in an elevator moving upwards, I think we said it becomes mg plus na, or z minus na. Check for me. While moving downwards, it becomes mg plus na. Check. Just check, like elevator. A body in an elevator, I have my reason. A body in an elevator falls on a body in an elevator. That falls under dynamics. That is Newton's law of dynamics. When you are doing forward force and backward force. When the body is in an elevator going upwards, and when it's in an elevator coming downwards, check for me what sign should be in between. I just want to use this and teach you this thing so you see what is happening there. When the body is in an elevator moving upwards, I know, it's doing me like it should be plus here. I'm coming down minus. Just check. Check, be sure. I don't want to make mistake. Just check. Which note are you? Where are you checking it from? Your notebook. Isaac Newton. Please check for me online for a value and elevator. What is the force? And you always use your own approximation of science. Check for me. Okay, let me see. Okay, you see what I thought you are doing your own thing. Let me see. And what you did there might be wrong for what I said. Let me just check. Okay, that word has plus. Why upward has minus? That means I'm correct. Okay, thank you. Bless. So we are correct. Downwards is this, upward is this. So this is the same as saying, this is the same as saying m into g minus a. This is the same as saying m into g plus a. Okay. Now please, if I know this, if this body, do you know why I'm using elevator to compare this? Because elevator has been constructed in such a way that it moves up and it moves down. Not like gravity is forcing it to move down when it's moving up. It has been constructed that way. So the same assumption is what we are having for an oil drop. An oil drop, we are assuming it that the electric field can make it be stationary. And as it's coming down, it is using the same principle that we use for an elevator. So that is why I'm saying that as this thing is coming down, the force I'm supposed to have here is going to be equals to mg plus ma. But notice that the whole of this force here, please watch. The whole of this force here, if you remember when we did ma equals to qe, this thing remember? So I'm going to be replacing this MA that I have here because there's also MA here. I'm going to be replacing the whole of this MA because we're talking about electric field with QE. Notice somewhere that I said that is the only difference with when it's in an elevator. So instead of mg plus MA, I'm now going to be having mg plus QE when it's moving downwards. So if that be the case, note this. It's the same thing with this principle. It's the same thing, the same principle. When an oil drop, this oil drop, you will learn it in your practical as American experiments. How they do the experiments to find out how the electron, the charges of an oil drop moves. I'm not telling you that the same principle you use for elevator that is moving downwards, that's what you use. But the only thing that changes is simply you knowing that Ma, which is force, is equals to QE. So you are replacing this MA that should be here with this QE. And if you check this thing very well, this thing is still the same thing as saying MA equals to MG plus QE, depending on what you are looking for. Note it. I said you should note it. You write it beside your notebook. For oil drop, this is the reason. We said it's the same principle with force on an elevator moving downwards. So if I've noted that, let's check what they asked me to find in. Okay, ahead, it's initial acceleration I'm finding. So to find the acceleration, it's acceleration I want to find. So to find acceleration, I will make a subject of the formula. So making a subject of the formula means that making a subject of the formula means that okay. Okay. plus QE over M over N. A equals G plus QE over N. Oh yeah. Please, do you agree that Q is equals to this? Do you agree that charge? Can I replace charge with this thing? Is it correct? Do you have counter into it? Okay. Since you agree, I can have that A is equals to I want to progress. Somebody say yes. Yes. I'm coming. So I'm coming. I will talk about it all over E. Then this is for Q. Then it's having E beside it, Chevy. And remember that everything is being divided by M. Do you agree? Yes. This can take care of this. This can take care of this. So that acceleration on an oil moving downwards is simply G plus G, which is equals to 2G. Am I confusing you? Yes. What is the confusion? What is the confusion? Yeah, this one. This one. I want see what I see. You will still write it. I will still write it. It's just that I like us to be on the same page. I like us to be on the same page. Check something for me. Check something for me. This is A. Get me acceleration here. If I want to get acceleration here, is it not going to the center saying A equals to mg plus QE all over M? Do you agree? Sure you agree? So like, I just said divide both sides by M so that I can get A, acceleration. So now that I've gotten acceleration here, I am not saying that this thing can be the same thing as saying A equals to mg over M plus QE over M. The same thing you solve with this is the same thing you get when you do this. But I'm not saying that we have to point it out because that acceleration actually has a standard formula when it has to do with an oil drop. And that acceleration is actually given by A equals to 2G. So I'm trying to show you how they derive that acceleration for oil drop that is given as 2G. So that is why we did this to substitute for Q. So we said that Q, if you remember from mg equals to QE, or you say MA equals to QE, but because it's an oil drop, it's moving down, the A will be replaced by G. This thing is the same thing as saying Q is equals to mg all over E. That is what Q is. Q can be many things. If you remember from here, Q equals to ME, but I have no business bringing ME here. I'm not talking about number of electrons here. So that is why I'm carrying this one to replace. So I can replace this Q here with mg over E. So it's all about knowing the occasion for something. That is why it looks as if in physics there are so many formulas. But it's all about the occasion. Why is this so? Why is this so? If you even remember that QE that I introduced in the first place, it was from mg equals to QE, where I said replace the MA that is supposed to be there with QE. So we are not saying that if we know that we replace that, we can also go back and say that the Q here is actually, if you make this a little, so it's just rotatory in order to achieve this. It's not confusing. It's you not refusing to accept what it is. If you solve, it will still give you the same thing. But when you see it in your textbook, y is A equals to 2G, it's because of this. So that is what I'm just trying to do there. So I'm now going to replace this Q with mg over E. Then remember that it has this E is only Q I replaced here. We still having E and M. This E and the M is this one. So just the Q is what I have here. So plus, so it's more like it's more like I said, it's the same thing as saying Q E over M. So I now have, this can cancel this, so I now have G equals to A. So you can now very well say that this can take care of this, and this can take care of this. So you're left with G plus G. So acceleration is equal to 2G. So what I'm saying in essence is when you enter exam hall and you see a question that has to do with oil drop experiments, and at the end of the day they tell you what is the acceleration of that oil drop, whatever they tell you, all you just need to do is to simply do 2 times 9.8. You get the point now? Just do 2 times 9.8. Very simple. There is no need trying to solve to kill yourself. So 2 times 9.8 is what? 19.6. So meter per second square. So that's just it. That's just what I'm trying to get at. Unlock this thing for me. Thank you. I'll solve number 14 and that will be it. That number 15 is what we did in first semester. We already did everything about number 15 in our first semester. If you remember when we did vector analysis, vector in 3 dimensions, where we did all those Lepression V dots, Lepression V dot V. If you remember, Lepression V cross V, all those things we did in first semester. So I'm not solving number 15. We already did everything about number 15 in our first semester. So I'll solve number 14. Yes, and we'll start capacitor. We'll start capacitor class. What is the electric potential? I can claim. What is the electric potential? Number 14. What is the electric potential at the surface of gold nucleus? Somebody should come and try that one for us. Number 14. It's simple. Last semester, if you check our videos for last semester class, you see many times where so many students will come to the board and solve. I don't know, our own will not be different too. Come and solve questions. Or did we wake you up too early? It's because of it's because of soft hand. We are giving you people soft hand this semester too much. If you ask others, you will see that we are not, like should I say, too intense as we should this semester, or should I say for the moment, and it's getting to you. It's almost as if we now give break, and that enjoyment is entering you too much. Please, someone should come and solve. See, Mark. Normally, Saturday class, we fix Saturday class by 8. We said when we fixed class in first semester. That's how we fixed it even second semester, 8. But this semester, we have a lot of things. And now it's getting to you. Oh yeah, someone should come and help me. You want to solve in your book? Nobody said let's solve in our book. How can you be solving in your book? Please, I don't have time. Okay. It's a shame. There you go, it's a shame. It's simple. One, come and help me. But see, first of all, V is equals to work done in carrying a unit charge. You see that true? Which is the same as saying FR over Q. And everything is the same as ER. V equals to ER. Equals to ER. Okay. Now, I need to check my E itself. Was E given? Did they give me E? Did they give me electric field? So let's use the right approach. The right approach is to always get the things we are given first. So I have radius equals to 6.6 times 10 minus 13, Shebi? So, and this is centimeter. Taking it to meter is the same as 10 raised to the power minus 2, which is equals to 6.6 times 10 raised to the power minus 15. Do you agree? Well. Now they gave me atomic number, that is Ne. Ne is 79. Number of proton, number of electrons is the same as atomic number. That Ne is 79 here. Now they said take charge of proton Q plus to be equals to 1.6 times 10 raised to the power minus 19 coulomb. But our goal is to find potential. Okay. So what I just need to do is the same as saying Q equals to Ne. That's just what it's saying. But this E here now is proton. So I'm going to have 1.6 times 10 raised to the power minus 19. The N here is this 79 and 79 equals to Q. But punch for me. Somebody will be like, how are you getting Q again? Using what you have, you know what they want you to get. So 1.264 minus 17. Sure, you said I did not do Q equals to mg or anything because I have nothing broken. There is a repair. It's not you come, you be telling your mind, he's just putting things he like. You know, I know some of you. So we've gotten that. Now, the next thing is to find our V. So from this thing, I know that this is also KQ over R squared, then R that is here. So this will cancel this. So V can actually be equals to KQ over R, which is equals to 9 times 10 raised to the power 9 into this charge that I have 1.264 times 10 raised to the power minus 17 all over my R, which is 6.6 times 10 raised to the power minus 15. It's very simple. Our V is equals to, give me the answer. What is this? What's the answer? Are you still with us? Yeah, Princess. Okay. Wow. That answer, princess, angel. So you've not told me the trouble you're looking for. So somebody just come call you princess, angel. Somebody that is passing, what would someone passing think? It's okay. Well, tell me what's the answer? 1.72
times 10 raised to the power
7
Yes.
volts. Please make sure it's correct. Okay, yeah, you are correct. In your textbook, they wrote their own as microvolts. Do you know why they wrote it as microvolts? Check something for me. If I carry this thing and come here, it becomes, 17.2, Shebi? Times 10 raised to the power what now? 6. Is it not true? And we know that 10 raised to the power 6 is the same thing as micro. Is it not true? So it will not be. Then, if you are putting it this way, everything here can actually be the same thing as saying 17.2 microvolts. So that's why you have it that way. I taught you all those things in the first semester. So thank you very much. God bless you. So that does it for our questions on chapter 2. We'll stop questions on chapter 3 now, but